Thank you, Mauro, and thanks to all the friends at the ISC Square Suisse Romande chapter. It's a pleasure and an honor being invited to speak at your event. And when Mauro asked me what to talk about, I thought for a second and I told myself, why don't you look back a little and see what your journey through your knowledge of computer security, really, because that's what we're talking about, has been through the years. And I came up with sort of a story of myself and how I saw things evolve through time. And this is what I would like to share with you, sort of a storytelling view on what happened through time. Now, many of you might know what set host is, and we'll get to that in a second. But yes, it's 30 years that I've been involved in computer security. Well, networks weren't there at that moment, and I've always been intrigued by communication, not just data communication, but also personal communication. It's something that I really still very much enjoy. But with computers, and I started age 13 with my first Apple II, and I built my own modem. It was at 300 bits per second, and I had to solder the little components in order to make it work and connect to the BBSs, which were the first thing that were not networked. They were island of its own, where you could exchange messages. But then I discovered the X25 networks, I discovered the CompuServe, and this also helped me in my other big activity, which was being a ham radio. So somebody who is interested in radio, data communication specifically, and allowed me to use computers to make digital communication using radio frequencies. And that was how I first discovered TCP/IP back in the late 80s. In fact, it's through a friend of mine who back then used to work at NASA. He was a researcher and a scientist. In 1988, he told me, look, Luca, check out this thing called the internet because it will be big. And back then, the internet was not really big. Back then, there were networks and computers still which had these kind of things, you know, green screens and, you know, letters. And yeah, this is VAX VMS, by the way. This is, if you see the date, it's quite fun because some aficionado has decided to revamp VAX VMS and made a free version of it that you can run on your hardware if you are really that nostalgic in going back in the past. But this is what we had. And, you know, set host is exactly what telnet is in the TCP/IP world. And set host was the way that I used in order to connect to other computers on, well, it was called DECnet, the network that was already working much before the internet really started to take place. In fact, when I was at the university, first at the Politecnico di Milano, that is how I got onto the network. There was no connection from the IP network in Italy and the rest of the internet. It just didn't exist. And so I would connect through VAX VMS onto my friend at NASA that I mentioned gave me an account onto one of the NASA VAXs at the Goddard Space Flight Center for a project that I was running with him. And that's how I was getting onto the internet. So there was an intermediate network to get to the internet. This was a little clunky, but of course things happened much faster. And, you know, at some point in time, we started to consider security as something that got in the way because it was a problem. And who was around on November 2nd, 1988? I was 20 back then. And this thing happened. The Morris Internet Worm happened. It was a virus containing that floppy, which is in the Computer History Museum in Silicon Valley today. And that internet worm blocked the internet, or what was then the internet, for 2 days, because people need to shut down computers and clean them and make sure that they wouldn't be susceptible to the virus any longer. So this was really the starting point of computer security. And by the way, this event was what prompted the creation of the CERT, Computer Emergency Response Teams, one of which we later started in Italy. The first CERT started with me and a few friends of mine at the University of Milan, where I later moved. So the problem is TCP/IP was really open. It was, in fact, its power, its advantage, and that allowed people to use it all across. At the time in which DECnet was there was DECnet for VAX, VMS, Digital Equipment Corporation computers, There was, of course, all sorts of other protocols. IBM had their own. Apple with AppleTalk had their own. There was no lingua franca. People and computers could not talk to one another. In comes TCP/IP, and that problem is solved. The problem is solved by creating a very open protocol. So open that if you go onto the request for comment document, the famous RFCs, and remember, I had to read them because there were no books on TCP/IP back then. They had not been written yet. Security considerations are not addressed in this memo. Most of the old RFCs were about this. So open up your computers, connect them together to one another, and just hope that nothing happens, because in the end, well, security was something that was not known. Or rather, we knew that there could be issues, and some people started to think in those terms. And so at some point in time, back in 1993, a guy by the name of Marcos Ranum wrote a firewall toolkit, FWTK, which for those who are a bit into the history of security, was really the first time that we had this concept of the firewall. But you know, firewalls were different than what they are today, in that a firewall was not a computer. A firewall was a system that included two routers, one towards the internet, or where you would think that you had the bad guys, a firewall towards the internal part of the network where you would hope you had good users, and then a DMZ with a bastion host. And that bastion host was the software component of the firewall system. I was more into networking. I loved the Cisco equipment. I loved Cisco IOS, and I learned a lot about how to configure it and make it run. And so together with my friends at the university, we started to work together on consulting to customers that needed to protect themselves from the problems of the internet. So I was taking care of the networking part, all of what are called in Cisco IOS terms, the access control lists on those routers, properly configured in order to tunnel traffic all the way to the demilitarized zone and the bastion host. This is how we got started with internet security. So opening up to the internet in a secure way, allowing people to start to not only use the internet for their own good, but also expose services to the internet. Remember, we're talking about times in which the World Wide Web was just starting to happen. So the concept of sharing data was more about FTP, file transfer protocol, or maybe Gopher and other old text-based protocols. In comes the World Wide Web, and first NCSA Mosaic, and then Netscape, and the whole internet changed drastically, completely. So much so that we started to have a few problems. First, we wanted to separate the internet from the internal network, and we were using private addresses to do that. There was a famous RFC 1918, which created specific classes of internet protocol addresses that could be used in order to create an internal network and an external network. The problem is the internal network needed to be translated in order to access the internet. And that translation was expensive to do. And in comes a company called Network Translations Incorporated, which was built back in 1993, that had a product, which is this. It was called the Private Internet Exchange. Now, Cisco was making routers and softwares, and they didn't have the NAT, Network Address Translation feature in iOS. And so they rushed on the market and decided to buy this company, Network Translations Inc., because they could provide this box. And you see it's got different Ethernet ports to connect the internal part of the network and the external part of the network and do network address translation. Well, they implemented NAT in the boxes and in the iOS, and then they could just throw away the PIX firewall, which they didn't, because it became a firewall at that moment. The features were improved, more application level controls, and here we are with a product that sold literally more than 1 million firewalls, and challenged the idea of needing to have a bastion host, which was a Unix-based bastion host, which is exactly what Checkpoint has been doing for many, many years. Back then, the competition was literally shred into pieces by the PIX firewall and the other appliances, some of which came through acquisitions like the Wheel Group that brought in what was happening, in fact, in the intrusion detection world and later intrusion prevention. That's when I was joining Cisco, 1998. At that moment, I was happy enough to be able to interview and work specifically on network security. Remember, Cisco was not working. They knew nothing about security. They needed people who knew about security in the first place to bring in that knowledge. And that's when I joined the company and noticed that literally they knew nothing. Exactly like the request for comments were saying, they had never addressed security, even within the company. So in the end, when a company is rich and has a lot of money, what do? They go out on the market and then buy more product. This was the VPN 3000 concentrator from Altiga that was bought. The company as a whole was bought, and I was the product manager for VPN and security in Cisco Europe at that moment. So the task of bringing to market that product fell on me, including all the problems with, of course, the Europeanization of the product, localization of the VPN client, and all of that. And you start to see that security is a whole lot more than just securing the network, but it's giving new services to those users who were starting to work from home a lot more. ISDN starting to be a big thing, and first lines with ADSL came out, very slow compared to what we have today, but still access from remote was possible. And not only we were giving remote access to the users that would connect back to the company network, but we also needed to access new applications such as Salesforce. Remember, Cisco was security. They said, you never open outside. This is the big data center. We have a few links which are international, but everything is secure within the network. And out comes Salesforce.com, and Cisco buys the solution and says, oh, now we have data of our customers, of our sales, of our contacts, and all of that outside of our data centers. And that caused a big problem, because where do you do security at that point? This problem is still there today, because while at the center you see a typical data center with a stack of different security boxes, some that filter the traffic that goes out from the corporate network, some that bring in traffic from outside, for instance, through VPN, for instance, for business-to-business partners. There's a lot of security boxes to manage. There's a lot of latency. There's a lot of delay in the traffic that one needs to take care of when you bring in traffic from your remote users. And then there is a cost that's also in the trusted network you see at the bottom. Those are typically would be MPLS networks, so private networks provided typically by telco providers that would then create a private network that is still connected to the internet. And you see those clouds, whether it's Google, CNN, or whatever other service there, those clouds will be connected to the internet. And so each node would have an access to the internet, would have a stack of those appliances, extremely complex to maintain, extremely expensive. You need to have specific staff to do that for you. Where do we end with this? What is the big problem? Well, the big problem happened this year, for instance, when everyone went back home and worked from home. But how? Now, surely VPN, that's exactly what was prognosticated way back when. When I was the product manager of the VPN 3000 concentrator, we started to push out the VPN client on everyone's machine. But this was Cisco. This was an IT company. Now everyone has a VPN. But VPNs do not solve some of the problems. For instance, you tunnel through the network through a VPN, all of the traffic coming from a computer, including any bad traffic that you might have because you've been infected with a virus. And that virus starts to check on what is lateral to him and gets in the data center through your secure VPN. So you're basically encrypting malicious traffic and you bring it in inside of your own corporate network, which is a bad thing. And so you needed to have different layers of firewalls and different protections within your own data center in order to secure yourself from VPNs. But can we do better than that? Well, there is a term right now that's Secure Access Service Edge, SASE. Gartner has been using it a lot lately. It's an evolution of the concept of zero trust network access. And it also falls within the concept of software-defined perimeter. And software-defined networking is what we're talking about, because these features must be performed in software rather than hardware, because you have a much faster time to develop applications and time to deploy these applications rather than needing to build specific hardware, specific chips in order to perform these security functions straight into the hardware. Performance-wise, new hardware is much better than it was. And so we are now able to perform a lot of these functions, not necessarily in the line cards where you would have the maximum throughput, but rather spread around in the cloud. And this is the concept of the secure internet gateway solution. You see from this timeline 2016 onwards, a lot more cloud has been going on because the cloud is where companies' applications now live, be it, internet as a service, rather IIS. So all of the applications that you bring outside from your own data center on the internet, be it AWS, be it Azure, or be it, of course, any other data center which is publicly connected. Or on the other hand, any software as a service solution, that will be an issue. So the whole push of infrastructure as a service to the cloud made further strides into the issue of not being able to secure a network which you don't have control of. So SASE gets into that direction and allows us to partly address the problem. Now, I will not be going into much detail about such a design, but what you will need to see first and foremost is the fact that we have security built into the infrastructure. This is mandatory. Security cannot be bolted on in a second stage onto an existing infrastructure. It will never work, especially when you have an infrastructure of which you don't have full control. What you have full control of will be your users, if you are, of course, in a corporate environment, and your servers. But when your servers are outside in a hosted data center or on a public cloud, well, the level of control you have is much smaller. You need keys everywhere. You need keys first to authenticate users. Second, well, to authorize them based on, well, their groups, their departments, not based on their IP address, not based on their layer 4 information, port, IP address, and things like that. It doesn't scale. It is very complex to maintain such networks if you go down into the technical details. Let computers do that. Let controllers and orchestrators that you see in the top part of this diagram help you with that by applying cryptography in the best possible way, both on the client side and, of course, on the asset that we need to protect the most, the host where we run the applications, while at the same time allowing that concept of zero trust network application, that is, do not show anything out on the network. Do not let everyone know that you have a critical piece of an application behind that protection unless the user is entitled to access that specific application. So long gone are the rules of firewalls allowing access to specific IP addresses and ports. You're blocking everything. You're blocking everything because the application will not be accessible from outside in, but rather from inside out. And that requires a lot of thinking, a lot of planning, not only on the networking side, but rather on the application side. The networking side will actually be rendered much simpler than what it is today with a full software-defined perimeter approach. In the end, what we're seeing is once again that shift, that change that meant that at first we had big computers at the center and dumb terminals, we used to call them like that, where you would have less intelligence outside and just simple data link or serial lines back then. And then we had more computer servers, and once again, we're pushing those servers out on the cloud. So you see is this going back and forwards between these two models with an additional problem. Right now, we must build security into this infrastructure. I would leave you with this. The Cloud Security Alliance is a group that works specifically in making sure that we do have shared security approach to the problem of securing the cloud. And securing the cloud means not only securing the servers and the services that are hosted on a cloud, but securing everyone, every aspect of what the cloud is about. That is, users which are using the cloud, no matter where they are, whether they are remote at their home, whether they are within their office, whether they are in a coffee shop or in an airport lounge or on board an aircraft using a satellite-based connection to the internet and doing work actively even when on board an airplane. This is a major revolution. The major revolution is security doesn't apply to the network any longer, in that the network is radically different from what it used to be. We need a completely different approach to security, and what Zero Trust Network, what software-defined perimeters, and what SASE is all about is exactly this, allowing a new approach to security in order to not only secure the network, but also secure the applications in the exact same way. I thank you for your time and your attention. These are my coordinates should you be interested in getting to discuss further this fascinating topic with me. Thank you very much.